Okay, sure. The last subject is something called influence lines. Influence lines for indeterminate structures. Indeterminate structures. It's just something basic. I don't want a lot of information from you. Just some basic information. You covered the influence line for statically determined structure and structure analysis one. Right? Structure analysis one. For statically determined structures, you covered the influence line. The influence line, what are we looking for? For a moving load across the beam or any structure or a truss. A moving load, 1 unit load is moving. What's happening to an influence? Influence can be a reaction, can be a moment, can be a shear, can be a deflection, can be a rotation, anything. It's called influence, تأثير. Okay, influence. So there is a unit load moving. Like if you have a bridge, 2-span bridge. You have beam, 2-span beam. Let's say this is a bridge beam. يعني جسر beam لجسر. A truck is moving. The truck can have 2 axles, عجلين, 3 axles, any shape. Distributed. When you go to bridge design, the first thing you learn is influence line. Influence line. So in order to find where is the location of the truck that will give me the maximum reaction or maximum shear or maximum moment, you need to construct the influence line for 1 unit load moving. So we construct the first step, construct the influence line for 1 unit load that's moving on the beam. Good? Then you place the load to maximize. Then you have the truck. They will tell you, okay, this truck, 3 axles, 3 أرجال. The first axle has 40 kg. The second axle, 40 kg. The third axle, 60. It's like a standard truck. Okay? Or unloading. Or unloading. Or if you have cranes, if you have cranes, they are carrying things, the goods from the airport or the ports, from the ports. What's happening as the crane is moving? Okay? So we can design them later on. So the first step is to construct the influence line. The second step is to place the load to maximize. To place the load to maximize, also you cover it for statically determined structures. And we will review it again in bridge design with Dr. Raja. Good? Good? So we have a unit load that's moving. If this unit load is moving on the beam, what's happening to the reaction? Let's say the first support. What's happening? When it's right there at the support, when it's right there at the end support, and when it's in the middle. This is called on. Good. So most of the time we are looking for reaction, shear, and moment. Reaction, shear, moment. Now the influence line for, just to give you a review, this is simply supported beam. Right? Simply supported beam. A and B. Okay. This is 1 unit load. When across this beam, a unit load is moving on the beam, will cross the beam, تطلع البيم. What's happening to the reaction at A? 1. So this is IL, influence line for the reaction at A. So you place the unit load at position. Each time, each position or each location, you calculate the influence. So when the unit load is right there at the here, 1. You are calculating this, which is 1. When the unit load is here, 1. You are calculating the reaction here. When the unit load is here, you are calculating it. So usually people get confused. When the unit load is here, they calculate something here. So you are looking at 1 point as the unit load is moving. Everybody knows this. Everybody in this class passed structure analysis 1. It means you know influence line. So he said when the unit load is here, at each location you are solving statically determined structure. At this location, equilibrium, find the reactions. At this location, find the reaction. So at each location, it's kind of you are solving a new beam. Statically determined, easy. So we said 1, it's here, So how much is the reaction here? 1. Take some of the momentary quantity. It's 1. So that's 1. When the unit load is here, this is 1, so this is 0. So this is 0. Influence line for statically determined structures, they are straight segments. They are straight segments, so done. So what's happening to the reaction here when the unit load is here? This ordinate, we call it ordinate. Similar triangles. You do similar triangles. And it's obvious, 1.5. What's happening here? Similar triangle. Here, similar triangles. So how about the reaction at B? 1 here, 0 here. What's happening to the moment at A? 0 all the way. This cannot develop any moment. So whether the unit is here, 0. Then what's happening to the moment here? 0. What's happening to the moment in the middle? If the length is L. Look. When the unit load is here, 1 is here. We know the moment here is 0. If the load is here, and if the load is here, it's 0. Right? So when the unit load is here, how much this one? And this one? 1.5. So the moment here is between section there. So moment there will be this. 1.5 times L over 2. So L over 4. This is all structural analysis work. Refreshment. Remember Breslau principle, Müller, Breslau principle, Breslau, Müller. Remember this? Principle. Okay. Did you cover this there or just drawing this? It's an easy principle. It's an easy principle. They say, we'll read it for now. We'll cover the statically indeterminate structure. We will use this thing here in the indeterminate structure. Easy one. They're saying if you want to find the reaction here, give a freedom for this support or this location to move in the direction of the reaction. In other words, move it 1. So move this one 1, and the other point is here. And they're saying the deformed shape is to some scale the influence line. Yeah. If I allow this one to go here 1, right? What's the deformed shape? If the joint become here, what's the deformed shape? Straight line. Straight line. So they're saying this deformed shape after moving this location, that's MB principle, is to some scale, the influence line. Yani you have to apply a scale factor. In this case, in static determinate structure is 1. Say, in indeterminate structure there will be a scale. There will be a scale, we will calculate. Don't worry about this. Just review with me this one now. How about the influence line for the shear at C? Shear at C. So look how easy. This C here. The distance here to the left of C over the entire length is this one. Then you jump 1, then you go there. How much is this one? L over 2. Over L is 0.5, right? So this is minus 0.5. Then you have a jump of 1. When it crosses, there is a jump of 1, which is 0.5. Minus 1 goes to 0.5, 0. How about this? How about the shear here? At 0.25 L. Minus 125. Jump to 0.75. 0. Okay. Yeah, if you calculate this one, this is what you get. And if you want to calculate, that's fine. Okay. When the unit load is all the way here, just before crossing. One is here, right? Let's see. How much the reaction here? 1.5. How much the reaction here? 1.5. Take a cut. This is 0.5, right? still in the section, did not cross C. So if this is 1, how much this one? That's 1.5. 1.5 and 1.5. This is a negative shear. Yes, this is a positive shear. And the opposite is negative. So on the right face, positive shear should be down. Up, so this is negative. Now when you just cross here, the reaction doesn't change. It's still there, but just crossed, right? So this one, how much on your section? You don't see the one. This is how much? 1.5 positive. So that's the jump. Minus 1.5. Minus the distance to the left over the span. That's to the left. You add 1, you jump, then you go wherever you go. Good? So you know, this is just a review. We know it. The good thing about it is what? يعني أحسن شيء فيها شو؟ They are straight lines, straight segments, everything can be found, but from similar triangles. يعني you find the ordinate of an influence at a key point. شوف يا جماعة هاي شوف. In real life, you just need the fundamentals. The details you can find when you sit in the office. تشتغل when you work in your office. You have a lot of time. You have advisor, 2 advisors. You ask them. The most important thing is you have the concept. يعني تجيب واحد من الشارع تيجي تقول له بدنا equilibrium. Sorry. أنت if you don't understand the concept of influence lines, how are they going to teach you? يعني لو افتح مخك وحط فيه, you're not going to get you. So you need just the fundamentals. Just the fundamentals. What's the influence line? There is a unit load that's moving across the structure. Can be a beam, can be a truss, can be a frame. What's happening to anything that you are interested in? أي شيء أنت مهتم فيه. Reaction at A, reaction at B, reaction at C. What's happening? How does it change as this moving load is going? So now we say, okay, what's moving load? Now the moving load is just a unit load. Now what's if you have actual loading? يعني في loading given to you, سيارات, which all of this. So then the second one is how to place maximize. يعني when you have a concentrated load, one concentrated load, okay, of 100 kilonewton. What's happening to the reaction at A? Is what you get from 1 multiplied by what you get from 100. And 100 times that. What if you have 2 of them with a distance between them? You place one at the maximum point and you see where is the second location, then you multiply by the ordinate. What if you have a distributed load? You place it over the area, if you're talking about the area of this one. There's distributed load. So it's the integration, the area times the intensity. Cover this again. This is just a review. I don't want to start with the influence line for indeterminate structure and you guys don't remember this. So this is anything you can find. Anything. Reaction, shear at any point, moment at any point you can find. No, both. To the left and to the right. Meter beam. Okay. We want to draw the influence line for the shear at 4 meters. Influence line for the shear at this point. شو حكينا؟ Fast. 4 over 10 minus 2. 6 over 10, which is 0.6. We go there. So 0.6. 1. Now, how we did this? How we did this is the following. So at each location, you calculate the influence. So when the unit load is here, 1, the reaction is 1. When you take your cut, no shear. This is your cut. This is your cut. This is the point. Right? This is the point. This is A, B, C. So that's your point B. So that's the reaction. Always the reaction is in the equation. Always the reaction in the cut. When the unit load is here, before cross, see what's happening when it crosses? There is a jump of 1. So we were actually this happens like this. The width of the support, عرض السبورت. The width of the column, if the support is a column. So to the left of the column, at the base of the column, to the right of the column. So the jump is through the column. Good? So to the left and to the left. So when the unit load is still there to the left, we are looking for this one. So that's the one. Where is your influence? What are you looking for? I'm always looking for, this is a positive VB. This is a positive VB. How it look like on the right hand cut? Take a check it out.
Positive.
This is in the positive direction. So I looked in the positive direction. If I get it positive, positive. Negative, negative. So look at this one. So that if the unit load is here from the equilibrium, you go back to your beam. From the equilibrium, this is 0.5. So that's 0.5 in this case, for this location. If this is 0.5 and this is 1 down, so this one is minus 0.5. Should be the other way. Should be the other way. 0.4, sorry. And this is not 0.5, this is 1.6. This is 1.6. This is 0.4. The sum of the reactions at any point for any influence is 1. 1 is distributed on all the reactions. The sum of the shear at any point is 1. It's my shear 1. Now, cross. Now we get this one. So this is how you draw. Okay, this one is 0.4. Negative. I have this point. Now I want to know what's this point here, which is, you don't see this. This become here. The reaction is still the same. You are still here. So this is 0.6. Now 0.6 down, up. This is 0.6 down. It means positive. So then you know it's this. And you know it's 0 here and it's 0 here. So you connect this segment, then you connect this segment. And that's the jump of 1. Good? Cantilever is the easiest. You have a cantilever beam. Okay. IL RA. Influence line for the reaction at A.
واحد لفوق.
All the time. When the unit load is here is 1, when the unit load here is. It's the only force for reaction in the y direction. So always equal the force. So 1 all the way. How about VA? Shear here. And I forget to ask you, the shear here is the same as the reaction. With the sign. نفس إشارة الرياكشن. نفس قيمته. With the sign. At the left end support, at the left end, the shear is the reaction. Good? With the sign. نفس القيمة, نفس الدايركشن. Positive, positive. Here, the shear here is the same as the reaction at B. The same as the reaction at B. But negative. Mirror. That's VB. Look, think about it. I'll draw it for you. So this is A. Okay, the left, right? Yeah, yes. Look at this. So this is AY, right? Right? This is AY. What is the shear at A to be positive on this cut? I just cut the column here. What is the shear here to be positive? That's a positive shear. Are they equal? And this is your beam. So this is down, this is up. So the shear at the left is the same as the reaction. Now look at the right. What's happening at the right? So this is B. Sorry, this is B. Y. What's the positive shear here? So they are negative. At the right, the same but negative. At the left, the same positive. Good? So what's the shear here? Is the reaction. 1. What's the shear there? At B. 0. No shear. Free to move. Is there a shear here? Of course. There is a shear. What's the shear at 1.5 L? Mahmoud. You know it? Mahmoud, you know it? What's the shear here? You know what's your case? This is the cut. This is your cut. If there is no unit load here, how much is shear here? 0. And how much the moment here? 0. So it's 0 till you reach here. Then 1 load. 1 here. Then it's 1 here.
بتكون 1 يونت لود على نص.
Any location. Any location. Here, here, here. If the unit load before that, nothing will develop. And they can deliver beam. How about the moment here? Influence for the moment here. Easy. Nothing. This is your section. Is there any moment here? Nothing. When the unit load is all the way here, the moment will be this direction equal this times 0.5L, which is negative. Just take a cut. Take a cut and show what you want. Of section, حط عليه اللي تدور عليه. Calculate it. What's the influence time for the moment here? 0 minus L. And when the unit load is here, the moment here is 0. When the unit load is all the way here, the moment is 1 times L. And it's this direction, it means negative. And we can do everything for the overhang. Same. Same. What are we looking for? Reaction here, moment here, moment here. In real life, guys, in real life. When you have a two-span beam, when you have two-span beam, and let's assume they are equal. Okay, let's assume they are equal. Okay, if you have dead load, W, dead, and live load equal W live. You have load. The dead load is the self weight. يعني الوزن الذاتي for the beam and slab. And you know what's the definition of dead load? شو تعرف dead load?
وزن فيكس مكان.
Exactly. Loads that always stay there. دائما موجودين. That's the dead load. They don't change. They are always there. They are the self weight, الوزن, and the self weight of the structure, which is everything. أساساً the structure. These are self weight. صح؟ بنينا الفريمز وبنينا السلاب وكل شيء. This is when you build the structure, the main skeleton of the structure. That's the self weight. There is additional dead load. Tiles, ceilings, mechanical, electrical. It's a dead load. يعني this will stay there. The tile will stay there, but it is added after you build the structure. So it's called superimposed dead load. So the dead load is two tiles, even in the software. There is the self weight plus superimposed dead load. They are dead loads. So live load, they come and go. They are not always there. Can be for a short period, hours, like this room. Every hour we go up, then people will come up. Then like in 6 hours, no people here. The university is closed till next day. So that's a live load. Bridges, trucks come, cars come, there is a congestion, there is the hand. This is a live load. Not all the time is there. But so you have dead load and live. When you go to the design courses, but throughout design courses, there is a way to factorize them. Now look, when you design this as a reinforced concrete and as a steel, reinforced concrete beam or a steel beam, what are you designing for? What do you mean design? Yeah, so we need the internal forces. What are the internal forces in a beam? Shear and moment. The main forces in a beam are shear and moment. If there is significant axial load in the beam, or the axial load, it's not just beam. It's frame out or beam column. Beam column. Not the truss. I'm talking about this beam. So there is shear and moment. There is internal shear and moment at every location. Good? So we need to find the maximum shear and we need to find the maximum moment. Right? So we said the dead load is always there. On both spans, على two spans. This is W dead, right? And the live load change.
الماكسيموم شير على المومنت الموزع اللايف.
Wait.
حسب إذا كان بوزيتيف أو نيجاتيف يعني جهتين.
Good. He says it can be all the way and it can be on one span, it can be on the other span. يعني ممكن يكون هون لحاله، ممكن يكون هون لحاله، ممكن يكون على الجنب. Either one span or the second span, the first or second or both of them. Good. Now, what the designer, the structural designer, he needs numbers from you. He needs to design. He needs from you what? MA. Is there a moment at A? The fire. يصرفون هذاك اليوم يقولوا في moment 0. So what does he want from you? The maximum moment in span AB. You need this. M max in span AB. We don't design every segment by itself. يعني نصممش كل متر. We design this one as one segment. Even if you are talking about reinforced, we design both of them to be the same segment. If you design reinforced concrete, you don't change the cross section. ما بتغير المقطع. You change the reinforcement. يغير التسليح. We change the reinforcement. So we need the maximum moment in span AB. Do you think it's positive or negative? Span AB, the moment is positive or negative? Of course positive. This will deflect this way. It was positive. Positive. Smile, positive. He also wants from you MBC. If they are equal, you tell him MAB positive equal MBC positive. Good. If they are not equal span, it means he needs this number. He needs this and he needs this number here. What else he needs? شو بده كمان؟ MB is 0, right? MB, there is a moment at B. The moment is 0 when you have end, when the pen or roller are end. There is a moment here. What's it? It's a negative moment at the support. Negative moment at the support. So he needs from you MAB, MBC, MB, negative. So if you're talking about reinforced concrete, where we put the hadid, where we place the reinforcement? At the tension side. Tension side. Why you put reinforcement at the tension side? Because concrete is weak in tension, strong in compression. So we put reinforcement. Good? We put hadid. So you need to know what is the tension. If you have positive moment, it's a smile, tension at the bottom. So the reinforcement down. If you have negative moment, sad, tension at the top. So the reinforcement is at the top. Then you have that. This is the design, just for you to know. يعني هيك الناس بتقول ترسم على التنشن سايد ولا الكومبريشن سايد؟ برسم على الرايت سايد. I draw on the right moment diagram. Positive, positive, negative, negative. Positive means tension at the bottom. Negative means tension at the top. Good? So he needs this.
دائما يعني بس يكون البيم إنه في سبورت يعني في سبورت بيكون عند البي عند النص بيكون
إن شاء الله 10 supports. There is a negative moment here, there is a negative moment, and a negative moment here. Any internal roller, there is a negative moment there. Good? Okay. It's not that easy. مش بسهولة بس هيك. Is this the end of the story? What's the end of the story?
نطلع الانترنال بين هذا البي لازم نحول على الانترنال بين أو عشان نقدر نحل لأنه هذا.
No, forget this. To solve this, he says this is indeterminate. This is indeterminate to the first degree. We learn how to do it. We learn. This is what we've been learning, right? We know how to do it. Remove this, find this reaction. We know how to do it. But this is the end of the story.
في لا
I need max. I need the max. What is the maximum moment in span AB?
في النص.
Okay. Look at this. Now we're talking about the loading. We're talking about the loading. Right? Now look at the live load. هاي اللي بنحكي اياها، شو اسمك انت؟ سيف؟ This is what I want to say. Dead load is there, you cannot avoid it. Live load, look. If we have live load here, we have live load here. What's happening to the moment here? How does deflect? How deflect? Like this. Hand fly forward. Put your hand here, this goes down, this goes up. Now, so if we are looking for the positive moment here, right? MAB positive, right? So if we have live load here, it adds to the positive moment. Let's see. Now, erase it. Put live load here. This goes down, this goes up. It means if you have a live load here, the moment here will decrease. This will raise it up. It will relieve the positive moment. It means to maximize the live load in span MAB, we only load this. And in the case you need to solve it, issue لازم تحله to find MAB max, this is the case, this is the live load.
بس لا بداية اللايف لود عليهم كلهم كيف حيصير الديفليكتد شيء؟
It will decrease. Regardless, it will decrease. But you know this live load here will cause negative moment here.
أقل less than on
شو بدك اعمل انت لسه؟ ابط اللايف لود على السبان الاولى ولا الثانيه ولا الثنتين. We know if we put it in the first one it will cause positive moment. الديد لود what does it cause؟ الديد لود شو بيسوي؟ positive moment here. Positive moment here. Right? And positive moment here. So live load if I put on this one positive negative. If I put here positive negative. So to maximize MAB, this is your case. This is your case. To maximize this live load only here. To maximize the negative on both. Life is not easy. Not easy. Especially if you have like 3 stars. أول شيء كمان مشاريع التخرج. It's what you do in the graduation projects. You know what they say? What they call this? Is the envelope. Envelope. You draw it يعني برسم لك الانفلوب maximize. He does this for you. The software does this for you. يعني he does something اللي أنت مش عارفه. مشكلة. You should know what the software is doing. It's called the envelope. You draw the envelope for you. The maximum case. Now, in order for you to know this, إذا ما بتعرف, this thing is what? Draw the influence line. You draw the influence line for the moment here. Draw the influence line and see. You will see when the unit load is crossing here, you will have a negative moment here. So when you load, when you put the load to maximize, you only load the positive areas. The creep تحمل the positive areas that if you want to maximize the positive. If you want to maximize the negative, then you put the load on the negative area. طبعا given that the load can have any length. The load بيقدر يكون any length. والlive load is any length. يعني هاي غرفة مليانة وغرفة ثانية فاضية. It's a possibility يعني احتمالية. Good. And likewise, if you want to see what's the maximum reaction here, will not change. Will not change. The live load must be here. Or يعني you need to draw the influence line for the reaction here and load it with the positive. Load the positive area with the live load. If you want to see what's the shear here, to the left and to the right, you load, you draw the influence line, then you place the load to maximize. You understand this? Before we go, how much time? 5 minutes? 5? خلصت? 5? Okay. Now this is just introductory for the influence line. Next lecture, Sunday, we will learn the fundamentals, just touch. What's the shape? Most importantly, qualitative. Qualitative, يعني the shape, the general shape of the influence line for a statically indeterminate structure. Just some guidelines. So if you have A, B, and C. If you want to draw the influence line for the reaction at A, the vertical, sorry, A1. Let's call it A1. A1. Now he said, at each location, we are solving statically indeterminate structure. And if I give you one, this is a question in the exam maybe. One or any force here, calculate the reactions. You remove one redundant, you put that redundant, you do the equilibrium. We know how to do it. This is what's exactly happening. Look, we're drawing the influence line. We move the unit load. When the unit load is right there at the support, how much AY? 1. 1. Man, with this one, if this confuses you in life, يعني this support is not the beam. This support, there is a column and there is the beam. يعني بعد اللود ما طلعت على البيم، واقف على الكولوم، موقف على اجر الطاوله. بالبيت عندك انت بتكون واقف، اذا دخلتها جوا كسرتها. غالب غير اللمبه يا محمود. وانك كاسر الطاوله، كم مره كسرت؟ Yeah. You stand on the column or on the chair. When you write directly, the column is under your foot. Nothing is transferred to the structure. Nothing. So this unit load is exactly at the column. So everything goes directly. 1, 1. So we know this point. That's one. The influence line. When the unit load is here, this is 1. So this is 0 and this one is 0. Because the sum مجموعهم is 1. So when the unit load stands here, look, I'm looking for AY. 0. When the unit load is here, 0. When the unit load is here, By is 1. When the unit load is here, Cy is 1. And that's, so I know these points. These are my key points. Look, this one, the influence line.
When we put unit load and C بيكون صفر بس.
Now, one fact you should know now, fact. For indeterminate structures, the influence line are straight segments, not straight segments. They are curves. Good? That's a fact. You should know this. They are curves. They are curves. Good? So this one, kind of, يعني whole one, it will decrease. It's not going to be straight. It's going to be either this or like this. It's curved. Either this or this. So if it's here, it will not, the slope will not switch. The slope will not switch. It will continue the same slope. So it's kind of this, then it will go to 0 here. Just, this is how it looks like. Qualitative. This is how it will look like. The deformed shape. Now how we calculate this one? At any point, point D. This point D can be here or here or here or here or here or here. Any point. Right? Right? If the unit load stands at this point D, this is the one.
Integration.
This is the one. What I'm looking for now, what I'm looking for? AY. At any location, I'm looking for AY. Right? And at أي مكان بدور على AY يا جماعة. How we calculate AY? Remember, we remove the redundant. We solve this one to find the reflection. Okay, right? And then we put 1 unit load here. Right? Then we calculate FAA.
Compatibility.
This times AY times FAA equals 0, we calculate AY. So, due to the one here, how much this one? Forget it. What's due to the one here? What's this? F A D. Deflection due to a unit load at D. Deflection at A due to unit load at D. Good. This, if the unit load is here, this is FAD. Now listen. What if we have one here? And we want the deflection here, we need to apply one here, right? What's this one now? Now your reaction is, this is F, A. When you have one here. Good? And what's this one will be due to the one here? FDA. سمعتوا Maxwell. Did you hear of Maxwell theorem of أعطيه على اللي بيكمل. Maxwell theorem of what?
Friction.
Reciprocal displacements. Maxwell theorem. Maxwell تعرف شو حكى؟ FDA equal FAD. حكى. شوف بالعربي. العربي. Deflection هون due to a unit load هون تساوي deflection هون due to a unit load here. Deflection here. تعرف بالعربي؟ Deflection here due to a unit load here, which is FAD. Equal deflection here due to a unit load here, which is FDA. In other words, عشان تريح حالك, you just apply one here. You just apply one here. You find FAA. You find FDA. You find XA. You find all of this one. Then they are ratios.
ولو كان عندنا بين بعد نقطة سي بين بس ما في عندنا لا هيد ولا بعد النقطة.
Where? Here?
over نعم. زي هيك. ده ترى الحل تاعنا ولا شو؟ إذا كان عندنا زي كبير مخطط بدنا مثلا بده يختلف عندنا الانفلونس لاين من النقطة اللي أخذنا الانفلونس لاين نهاية.
Yeah, you need to calculate. Now you have this one. If this one goes down, okay, if the unit load is here, what's happening here?
بكل الجلد.
If you have one here, maybe the reaction will be up or down. Okay, up or down. Good? So this is Maxwell theorem of reciprocal displacement. FDA equal FA. So the only thing you need to find is mine. You apply one here for the reaction. You apply one here. You calculate FAA. And you calculate the deflection at any location. So if you want to know what's AY look like here, what's the value of AY here, we know how to calculate this one, right? Then with this one, when you have it here,
يعني قانون ماكسويل بنضرب وسطين بالنسبة لي زيها.
the reaction at any point is delta at that point due to a unit load at the location of the reaction divided by the FAA, which is the deflection due to the unit load at the redundant location. Okay, you know what's this? It's what we call scale efficient. This is the stiffness, yes. 1 over that, the stiffness. That's true. But this is what, remember I said, the shape of the influence line will look like the deformed shape, or the deflection shape. زي شكل deflection. To some scale, they are the same. The deformed shape is almost the same shape. But what's the value? Scale. So the only thing you need to do is calculate FAA. Easy, we know how to calculate this one. Then calculate FDA at any location. From the conjugate beam or any method you know, then AY can be plotted at any location. We continue on Sunday.